Hello, in the part 1 video on logarithm, we learned about the fact that when you have y is equal to a raised to n, then a is called the base and n is called the logarithm or index. We had some examples, and just to remind ourselves, if we have 216 and we say that in indices form this is 6 raised to power 3, then this can be written as the log to base 6 of 216 is equal to 3, or in other words 3 is equal to the log to base 6 of 216. The log of 216 to base 6 is equal to 3. There are different ways of reading that. Also, if we have log to base 4 of 6 is equal to y, then this means that 6 is equal to 4 raised to power y. In general, therefore, the log to base a of y is equal to n, or simply this can be written in indices form as y is equal to a raised to n. We made a statement that this can help us to be able to write logs in terms of indices and indices in terms of logs. Now, in this video, we are interested in the logarithms of numbers that can be expressed to the base of 10. Examples are 1, 10, 100, 1000, 10,000, 0.1, 0.01, 0.001, etc. Now, you probably wonder how we are going to work out the ones that are in decimal points. But first of all, 1 is the same as 10 raised to power 0. When we worked on indices, we made a conclusion that any number raised to 0 is equal to 1. So 10 raised to 0 is equal to 1, or simply 1 is equal to 10 raised to 0. Now, 10 is simply equal to 10 raised to power 1. 100 is equal to 10 raised to power 2. Now, each of these can be written in log form, and so I will be working with log form and indices together. So here we have the log to base 10 of 1 is equal to 0. And this one gives us log to base 10 of 10 is equal to 1. This other one is simply log to base 10 over 100 is equal to 2. So 2 is the log of 100 to base 10. Now we also said that when we are dealing with the log to base 10, it is just okay to write this without writing the base. So the log of 1 is equal to 0, the log of 10 is equal to 1, and the log of 100 is equal to 2. If we continue writing the above, we continue to up to 0.001, we are going to end up with the following. For 1000, we are going to say this is 10 raised to power 3, which can be written now, dropping the base, I just write for you, log of 1000 is equal to 3, or rather 3 is equal to the log of 1000. Likewise, for 10,000, we have this as 10 raised to power 4. Now again, just for those who probably don't know, To have this power here, we simply count the number of zeros that we have here. If we are having numbers that are in terms of 10, 100, 1,000, 1,000, 10,000, etc. That's how we count, and then we end up with log to base 10 of 10,000 is equal to 4. Now again, I said we don't have to write the base because for sure we are dealing with the logs to base 10. Now why is that? It is because the log to base 10, which are actually called the common logarithms or the common logs, are already known to be logarithm to base 10 of any number should be written simply as log, in this case of x, is equal to y. So the log to base 10 of any number, you simply write log of x, log of w, log of 10, log of 20. Now that I've mentioned log of 20, we will talk about it in another video. But for now, let's understand that common logarithms are actually logarithms to base 10. Now, we have said the log of 10 is equal to 1. And the log of 1 is equal to 0. Now, remember, we are talking about common logarithms here. Now, what does this tell us? This tells us that all numbers between 1 and 10 have their logarithms between 0 and 1. So all numbers between 1 and 10 have logarithms that lie between 0 and 1. Now thinking about the numbers that I gave up here, 0 0.1, 0 0.01, 0 0.001, sorry, 0 0.01 also, and etc. To express these numbers such that we have numbers between 1 and 10, we need to first of all write them in standard form. Now, writing this to standard form gives us 1.0 times 10 raised to negative 1. Again, this other one is 1.0 times 10 raised to negative 3, and this other one here is 1.0 times 10 raised to negative 2. Now, if you look at this, you will see that 10 raised to negative 1 can be written in log form already. Now, again, we already know that the logarithm of 1 is actually 0. And the logarithm of 1 in this case is also 0, and that is also 0. Now, I want you to note that if we have to express these numbers in log form, then what we need to remember is that this one can be written as 10 raised to 0. We are multiplying by 10 raised to negative 1. Again, this other one, we are simply writing 10 raised to 0 times 10 raised to negative 3, and this one 10 raised to 0 times 10 raised to negative 2. Now if you look at this and we remind ourselves of the laws of indices, we're actually adding the power in this case, and therefore the log of this, or this number, can be simply expressed as this one is simply expressed as this, and this one is simply expressed as this. Now this is explaining maybe too much, but I want you to understand the logs even as we go to other levels of logarithms. So for this video, let's end it there, but in the next video we will go further to understand how do we get the logarithms that are of numbers other than 10, 1, 1000. If we have a number like 20, if we have a number like 30, if you have a number like 5, if you have a number like 6, how do we get their logarithm and therefore be able to express them? Thank you for watching. Subscribe kindly to this video, like and share with your friends who need maths help. Thank you.